AP Calculus, section 6.2, page 1. We are doing U-substitution today, and U-substitution is a way to take this complicated integral and rewrite it or shrink it down as something that's just a little bit neater and cleaner to do. So if we start off, we're going to say that U is 4x squared plus 3. Then we'll do the derivative here. So du dx is 8x. And then we'll go ahead and multiply this dx up here because I want to separate out the u's and the x's. So du is 8x dx. And now we go back into the problem and we're going to substitute out just for the u. So we see 8x. And then this 4x squared plus 3, well, that was u, so we have times u squared dx. Rearrange this and pull the u's up front and everything with the x's in the back. So we'll have u squared times 8x dx. At this point then, we need to replace out this 8x dx. And we see right here that 8x dx is exactly du. U squared times du. Now we have an integral that we can handle. It's very nice, clean, and we do the antiderivative here, which would be 1/3 of u cubed plus a c. And we'll trade back that u for the x's, and we end up with 1/3 times 4x squared plus 3, that was our u, cubed plus c. And that's the final answer right there. Looking at this next one, let's start off by rewriting this cube root as the quantity 3x minus 4 to the 1/3. Generally, when we have a quantity that's raised to a power, that is our u. So we'll use u is 3x minus 4. Du then, the derivative here is just 3. Oops. Du dx is 3. And then let's multiply by that dx. So du is 3 dx. Now we go back and we'll substitute out just one thing at a time. So first, let's trade out for that u. So we have u to the 1/3 times dx. Now we're basically trying to turn all the x's into u's. So we'll look right here and we can see that dx is 1/3 du. U to the 1/3 times 1/3 du. Pull that constant multiple out front. 1/3 times the antiderivative of u to the 1/3 du. Now do that antiderivative, and 1/3, let's see, this would be add 1 to the exponent, so 4/3, divide by the new exponent, puts a 3/4 out here, plus a c. And this will give us 1/3 times 3/4, 1/4 u, which was 3x minus 4 to the 4/3, and then plus a c. And there's the answer there. All right, lots of steps. We can maybe eliminate one step for sure right here. If we notice we start at u, and then we did du dx, and then both times we multiplied up that dx. So at this point we can start skipping this step right here where we write du dx. It's not necessary to write this step. We can just go right to the derivative. You just have to remember when you do the derivative du dx that du comes down and the dx is on the other side. It's kind of doing that derivative and multiplying through by that dx all at once. All right, again, to choose a u, typically if we have a quantity that's raised to a power, whatever is raised to that power will be that u. So in this case, let's use u is 2x squared plus 1. And then we'll do the derivative. It's du dx, but remember, we're holding that dx to put it up on the other side. And the derivative of this 2x squared is a 4x. And there's the dx that we multiplied out from the left. Replacing out just the u, we have x times u to the 6th dx. Again, do some rearranging here and pull the u's up front. U to the 6th times x dx. And we'll need to replace out that x dx. And x dx, oh, right there is x dx. And that's got to be 1/4 du. U to the 6th times, here's a 1/4 du. And let's pull this constant multiple 1/4 out front. And now we have a nice clean integral. We can do that antiderivative. Here's the 1/4. And then this one, u to the 7th, 1/7 comes down, plus a c. And we end up with 1/28 times u, which was 2x squared plus 1 to the 7th plus c. And there's that final answer. You can always check by doing a derivative of that answer. When you do a derivative of this answer, you better get what you started with on the inside. If we can kind of just imagine this, we would pull this 7 down in front, 7/28, that's 1/4 times this quantity right here to the 6th, but then times the derivative of the inside, and the derivative of the inside, 4x. And that 4x times that 1/4 out front would be just that x that we had here. All right. Last one for this page. Let's look at this one. The integral of 2y over 1 minus y to the 7th. Let's rewrite this 1 minus y to the 7th as a 1 minus y to the negative 7th, and we get rid of that fraction. Let's set up our u then. Again, anytime we have something raised to a power, typically that quantity on the inside is the u. Oops. U is 1 minus y. So du is the derivative of this, so a negative dy. And rewriting, while I do this at the same time, I'm going to take this 2 and pull this 2 outside. So 2 integral, we have a y, but then here is the u to the negative 7th times dy. And I'm going to do some rearranging here and put the y's at the back. And to start to substitute out, we need to replace a y dy. Well, right here, dy we can absolutely replace with negative du. So we have 2 u to the negative 7th times a y times a negative du. Let's take that negative and pull that around front. And we have a problem because we still have a y in here. Still have a y. Oh boy. Oh, let's come up right here. Let's take this line right here and let's solve for y. And that will be 1 minus u. So now we can come down here and replace out this y with a 1 minus u du. And we're still in a little bit of a trouble here because there is no product rule for integrals. So we need to distribute this u to the negative 7th through. And we'll get u to the negative 7th times a u to the negative 6th du. Now we can anti-differentiate each piece. So let's come up here. This negative 2 is still out here. And we'll do the antiderivative. U to the negative 7th. Let's see, add 1 to the exponent. That'll be a u to the negative 6th. Divide by the new exponent. So negative 1 over 6. Minus, let's see, add 1 to the exponent would make that u to the negative 5th. And we have then a negative 1/5 out here, so that makes this positive 1/5 plus a c. Distribute that negative 2 through, and that'll give us 1/3 u to the negative 6th minus 2/5 u to the negative 5th plus a negative 2c. And now let's replace out that u, so we have 1/3 times u was 1 minus y. 1 minus y to the negative 6th minus 2/5 times a 1 minus y to the negative 5th plus, all right, now c represents a constant. Negative 2 times that constant is just a different constant. So rather than writing plus a negative 2c here, we just do a bigger c. This c is not the same as that c. It's just a different constant. It's negative 2 times this c. If that bothers you using the two c's, then call this one c sub 1 and call this one c sub 2. But this is your final answer right here. More U substitution on page 2.